We've looked at direct and inverse proportion in worded problems, but today we're going to be looking at direct and inverse proportion algebraically. If y is proportional to x, it will always make a straight line going through the origin. We could write this as y fish x. The fish is the Greek symbol alpha, and it means is proportional to. If y doubles as x halves, we say that y is inversely proportional to x, and the graph looks like this. We can show this as y fish 1 over x, or y is proportional to 1 over x. You can replace the fish with an equals if you multiply the right hand by k. We call k the constant of proportionality. Let's have a go at these questions. In this question we're told that y is proportional to x, and when x is 15, y is 3. And we're asked to find the value of y when x is 21. So we know that y fish x, or y is proportional to x, and we can replace that fish, or the alpha, with an equals by multiplying the right hand side by k. So y equals kx. We can then substitute the values that we know, because we know when x is 15, y is 3, into that. So we get 3 equals 15k. Draw our lines, and we can see the 15 before the k. We can divide both sides by 15 to just find the value of k, which will be 0.2. We can then rewrite the equation we had earlier, y equals kx, but with that 0.2 in it. To find the value of y when x is 21, we just substitute 21 into this, 0.2 times 21, and we find that y is 4.2. In this question we're told that y is inversely proportional to x, and when x is 12, y is 3, and we're asked to find the value of x when y is 102. We're going to start by writing out y fish 1 over x, y is proportional to 1 over x, and we're going to replace that proportionality sign with an equals by multiplying the right hand side by k, so y equals k over x. We know that when x is 12, y is 3, so we're going to substitute those values in, and we're going to put our lines in, and we want k on its own. Stopping it is that over 12, so we need to times both sides by 12. So it will be k equals 36. Going to rewrite the equation, but with k as 36, and we're going to substitute in y as 102. Notice that the x is at the bottom of the fraction, so we're going to put our lines in, and we need to get x on the top, so we're going to times both sides by x. And then what we're going to do is get rid of that 102 by dividing both sides by 102. So x equals 0.35 rounded to 2 decimal places. In this question we're told that y is inversely proportional to the square root of x. When x is 36, y is 13, and we're asked to find the value of y when x is 121. So this time y fish 1 over the square root of x. Again, to get rid of the proportionality sign, we're going to put an equals, and we're going to times the right hand side by k. We're going to substitute in the values that we know. We know that when y is 13, x is 36, and put our lines in after we square root the 36 to find 6, and times both sides by 6 to get rid of that over 6, and we find that k is 78. Rewrite the equation, but this time with k as 78. And we're told that when x is 121, we need to find y. So we're going to substitute in 121, and that becomes 78 over 11, and which was rounded to 7.09 to 2 decimal places. Let's finish with this. Discuss why the graph for inverse proportion can never touch the origin. If you know, let me know in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free GCSE papers and predictions, and you can even save your scores with a free account. This video is part of a larger GCSE course that you can follow along with at onmaths.com.